Half a day students, this video is coming to you a little bit late, but it's very simple. Hopefully we all get it, and let's just get straight into it. We're going to be factoring by grouping and then learning how to factor difference of squares. We're just going to go into the first example without much explanation. Basically, what we're going to do is group the first two terms and the last two terms, factor what each of them have in common, and then you'll see what we do from there. So in my middle, the sign here in the middle connecting the two, so for example, if I have ax plus ay, if this middle operation is addition, then it makes things very easy because parentheses don't change addition, right? So everything stays positive. When it's negative, we have to do an extra step, but when you have plus there in the middle, then it's pretty easy. We'll just put parentheses around the two different sets of terms, our first two and our last two. From here, I want to look at each of these terms individually, the sets individually, and see what they have in common. Looking at this first one, ax plus ay, I know they're both divisible by a, right? So I'm able to take out a from each of them. I'm actually going to make this a different color inside just because this is going to be important later on. Okay. Plus, this second set, they both have b. So I can factor out b from each of those. And then I'm left with bx divided by b is x, by divided by b is y. And you'll notice that, okay, I put these in different colors. You can see very easily that they have the same, they're both multiplied to the same thing. And once we get to this step, it's really easy. Once we have the same thing inside the parentheses, I'm actually going to be multiplying. So I'm going to put these two terms together, a plus b, and multiplying that whole thing to x plus y. I'm able to do this because of distribution, but as long as we get it to this step, we should be able to go down to here very easily. Just memorize how it is, honestly. Yeah, we'll do a bunch more examples. Moving on to our second example, I'm just going to rewrite it. AB minus B plus A minus 1. Since I have plus in the middle, again, it's going to be very easy. All I'm going to do is put parentheses around the two different sets. Looking at my first one, AB minus B, each of these terms are divisible by b, so I'm going to take out b. And again, I'm left in the inside. Let's see what we have in here. AB divided by b, I have a. Negative b divided by b is going to be negative 1. Looking at the second one, it doesn't have anything in common, so I'm actually just going to make it b plus a minus 1. I don't have anything to factor out there, so I'm going to leave it as it is. It still works. For this one, what I'm actually going to do, so I know I'm going to multiply something by a minus 1, right? Some students might just go straight to just multiplying b, but there's always this invisible coefficient in front of everything, right? Everything's understood. If there's nothing in front, it's multiplied by 1. So I'm actually going to multiply this whole thing by b plus 1. And again, if you're not sure, you can FOIL it. So let's actually just check. So this is our answer, but I'm going to check here on the bottom with red. B plus 1 times a minus 1 using FOIL. First, we have AB outside minus B inside plus 1a last minus 1. And you'll notice that this is the same as the original, right? It's the same. So this answer was correct. And again, for this section, it's really nice because if ever you're not sure if your factorization is correct, all you have to do is multiply it and you should get the original equation if you factored correctly. This one, we'll rewrite it. Again, we have plus in the middle, so all I have to do is put parentheses, 3a squared minus 6ab, be careful when you rewrite, plus 2a minus 4b. Factoring out what we have in common, 3a squared and 6ab, they both have at least 1 3 and 1a, so I'm left in the inside. 3a squared divided by 3a is just a. Negative 6ab, I know it's going to be negative 2. 1a is taken out, so I'm left with b. Plus 2a and negative 4b, I can factor out 2. And I'm left with a minus 2b. Works out nicely, this is the same. A minus 2b times the sum of my coefficients there, or the factors on the outside, 3a plus 2. Again, multiply if you're not sure. Let me just put in some equal signs here. Okay, moving on to this one. Now I have a negative. So when it comes to negative, what you're going to have to do is, so with the negative here, what I'm actually going to do is keep that negative sign with my 2x. So I'll show you how you do it here. So okay, so I have x cubed plus 3x squared. No issues there. I'm going to add. I like to add. So I'm going to keep this negative 2x. Keep that negative with the 2 minus 6. And from there, you should be able to do the same thing. Factor out x cubed and 3x squared. They both have at least x squared. And then I'm left in the middle, an x plus 3. Looking here on the right side, you can factor out 2 from each of them, but also I want to make sure that the signs and everything matches this x plus 3, right? I want to make sure my leftover matches x plus 3. So for this one, if I want my first term to be x, I'll actually factor out negative 2. Factor out negative 2, and then that way I'm left with x plus 3. From there, I have x squared minus 2 times x plus 3. Moving on to another example. I have another negative, so I'm going to add and then keep that negative with a 6. 8m squared minus 4mn plus negative 6m minus 3n. Okay, so this first one, I know they're both divided by 4. I can pull out at least 1m. Left with 2m minus n. For this one, I want my first term to be positive again, so I'm going to actually pull out negative 3. I have 2m plus negative 3 divided by negative 3 is going to be plus n. So even though I'm looking at this, it's really close, but I end up with a 2m minus n and a 2m plus n. There's nothing I can do here. There's no way it's ever going to match. So actually, once I get here, I can try factoring out positive 3 instead, but that'll change this to be negative. So if only one of the signs is different, meaning to say, if it was negative 2m plus n, then I could just factor out a negative 1 and change the sign of each of them. But when only one of the signs is different, then you actually can't factor it at all. So there's no way for me to fix this. This actually is going to be, cannot be factored. Okay. Looking at this last one for the first example, 35 minus 42m plus negative 18mn plus 15n. Factoring this first one normally, 35 minus 42m. And this actually looks a little bit different than I'm used to, right? It's kind of backwards. So just a hint, so the test, they will give you some where It's like this. It's kind of a trick question. I think actually it's a good idea to just flip it right away. There's a way to fix it in the end, but it's easy to get it out of the way right off the bat because I can already see 35 minus 42m. I have my variable in the second one, so I'm actually just going to flip this to be negative 42m plus 35. Just because I want to keep the same signs, but I want it to be closer to what I'm looking for or what I'm used to. Okay, from here, negative 42m and 35. I might actually just factor out a negative here. We'll see, but I'm actually just going to factor out a negative because my m is negative. I'm just going to try it out. Factoring out negative 7. I'm left with negative 6m plus 5. Looking at the second term, since I have negative in my first one and I want it to stay negative, I'm going to factor out positive 3, and they both have at least one n. There I have negative 6m plus 5. And it works out really nicely, this one, because I did that first step of flipping the original ones. I'll show you how to do this without doing that in the beginning, but if you can, whenever you see something weird where you see it's backwards kind of, just switch the places of the two, but keep the signs with the appropriate term. So the negative 42m, it still is negative, the 35 stayed positive, but I just switched the places. Okay, and then from here, since I have the same in the middle, the negative 6m plus 5, I'm going to actually just do negative 7 plus 3n. And once you're here at the end, you don't need to put it in any order. Negative 6m plus 5. You can make it be 3n minus 7, but it doesn't really matter, to be honest, once you're there at the end. Now let me try to fit here on the bottom how to do this without switching the places in the beginning. So I'm left with 35, starting with 35 minus 42m plus negative 18 mn plus 15n. Factoring normally, okay, these both are divisible by 7, so I'm left with 5 minus 6m. And here again, I notice, okay, I want my first term to be positive. Maybe I'll factor out negative 3n times 6m minus 5. And you'll notice, okay, these two, they're very close, but they differ in signs, right? So the 6 is negative on the first one, but positive in the second one. The 5 is positive, and then it turns negative. If ever it happens where both of the signs are wrong, you can fix it by factoring out negative 1 from one of them. So for this last one, I might factor out negative 1, or I'll actually just change it to be plus 3n that I factor out. So I'm left with 7 times 5 minus 6m plus 3n times negative 6m plus 5. From there, 5 minus 6m and negative 6m plus 5, those are the same. So what I can actually do from there is 7 plus 3n times 5 minus 6m. Doesn't matter the order, both fine. So these actually come out to the same thing. And I'm actually seeing a problem in this first one. That's actually should be net positive 7. Positive 7. And I'll just erase that. It should be positive. But your answers turn out the same in the end. Just be careful of signs. Looking now to the second part of the video, difference of squares. This one is very, very, very easy, and it's very, very important. You'll be using it throughout this semester. Difference of squares. First of all, we're just going to look at the product of two specific binomials. So I want to see first 2a plus 5 times 2a minus 5. You'll notice that the terms in these are the same, except one's plus, one's minus, right? So let's go just start off by foiling this first. So we have 2a times 2a becomes 4a squared, right? 2 times 2 is 4. A times a is a squared. Minus 10a plus 10a minus 25. And then from here, combining like terms, 10a plus negative 10a becomes 0, so they cancel each other out. We're left with 4a squared minus 25. It's important to note that whenever you have this where it's the same term, where one's positive, one's negative, it's going to cancel out the middle term, so you're left with the first and the last. And you'll see I can actually rewrite this 4a squared as 2a squared, right? 2 squared plus 2 squared times a squared minus 5 squared. So this is an important thing because these are actually the same, 2a and 5, as my original terms, right? 2a and 5, 2a and 5. So it makes sense that we have this general formula now that we're going to be using, which is, write it bigger. If you have two different squares, we have, for example, a squared minus b squared. Its factorization is going to be a plus b times a minus b. And we're going to see it in use in the next several problems, but this is like my favorite formula. Okay, so we have a squared minus 4. First thing I want to do is write it as a difference of squares, and it's important to note that this only works for differences. So it only works when you have a square, perfect square, minus a perfect square. So a squared I can rewrite as a squared minus 2 squared. And you don't always have to do this step, but it's important to show it for this video for you guys. But if you can go straight to its factorization, then go for it. Okay, so I know this is going to be using the formula a plus 2 times a minus 2. I take each of my terms, add them, subtract them, multiply them. Again, if you're not sure, multiply it out, see if you get the same answer. Okay, 25x squared minus 9, I'll write it as a difference of squares. We have 5x squared minus 3 squared. From there, I have 5x and 3. I'm going to add them. (5x minus 3). 4c squared minus 25. 4c squared, I know that's going to be 2c squared minus 5 squared, which is 2c plus 5, 2c minus 5. It only works when, for these, look at this first one where you have 25x squared or 4c squared. It only works when that coefficient is also a perfect square. Now let's look at this one, x to the 4th minus 1. So for this one, we're actually recalling some of the properties of exponents. So I actually know that when I have an exponent raised to an exponent, you multiply it, right? So to find the square of this, or the square root of this, x to the 4th, I'll actually just divide this exponent by 2. So it's actually just going to be x squared is squared minus 1 is just 1 squared, right? From here, I can say, okay, this is equal to x squared plus 1 times x squared minus 1. Whenever you do this, when you have this x to the 4th power, it's usually going to have an extra step of one more round of factoring. You always want to look at your final answer and see, can I factor anything else out? So looking at this one, x squared plus 1, there's no factorization of a sum of squares. So this one is good. We don't need to factor that at all. X squared minus 1 on the other hand, x squared is a perfect square, 1 is a perfect square, so this one I'm actually going to expand again. So I'm left with just copying this x squared minus 1 down, or x squared plus 1. And this x squared minus 1, I'm actually going to factor one more time. I know this is going to be x plus 1 times x minus 1. So we have 2 rounds of difference of squares, so just be careful with that one. Looking at this one, so I'm going to factor a trinomial how I would normally, and then do the one step, I'm probably going to have to use difference of squares again. So I'm going to say, okay, it's going to be different signs. I'm looking for a difference. Now I'll look at my factors. So factors of x to the 4th are just x squared and x squared. Factors of 16, I have 1, 16, 2, 8, 4, 4. Which one of these will give me a difference of 15? I already know it's going to be 1 and 16. So I'm left with x squared. I have 16 and 1. One has to be positive, one has to be negative. Since this is a negative 15, I'll make the 16 be negative, the bigger one negative. This is going to be x squared minus 16x squared, negative 15x squared. So this is the correct factorization. So this is going to be equal to I'll use a different color so I have a different work. X squared plus 1 times x squared minus 16. I have to look at this again. Can I factor anything else out? This x squared plus 1 is done. Cannot do anything for addition. X squared minus 16, are any of these perfect squares? X squared is a perfect square, 16 is a perfect square, so I'm actually going to factor this one more time. So we have a round of difference of squares, right? Factorization. So this is going to be x squared minus 4 squared, so it's going to be x plus 4 times x minus 4. Okay, so just do more and more practice. It'll get a lot easier, I promise. You're going to love factoring after this. There'll be one more example, which we'll move on to now. X to the fourth minus 5x squared plus 4. Rewriting it. Just so I have more space. Same sign, I'm looking for a sum. We have x squared and x squared. We have 1, 4, 2, and 2. 1 and 4 will give me a sum of 5, right? They're both going to be negative. So my factorization of this is actually going to equal to x squared minus 4 times x squared minus 1. Looking at this, I have two different differences of squares. I can factor both of them. X squared minus 4 is going to be equal to x plus 2 times x minus 2. X squared minus 1 is going to be x plus 1, x minus 1. So I promise you'll get a lot more comfortable with the difference of squares, but it's one of the most important and I think most useful formulas that we have for factorization, especially. Yes, that's it. So I hope this is okay for you. We'll be online on Wednesday if you have any questions or you want to go over some examples. Have a good day.